So the two definitions, part 1 and part 2 for the FTC should be always be in your mind, although the calculations later on will be much easier using the same concept, but you should always know that what is the concept behind an integral. These two equations are always very important. The first equation was integral g of x, integral a to x f of t dt, if the function f is continuous on the interval ab, then this guy is actually the derivative of this function. This was the part 1, and the part 2 made it more easier from here, and it said if you have integral a to b f of x dx such that this function f of x is continuous on the big interval ab, then you don't need to worry about this. Simply look for the antiderivative of this, the function on which when you applied the derivative to get this. When you will get that function, which will be the capital F, this will be the capital F, then the answer for this whole guy is equal to the value of this function at the upper limit point minus the value of this function at the lower limit point. Means the answer of this guy under the integral is equal to the answer of the original function at the two limit points. So these two theorems are linked together. One is the basic and the other is the most general version of the fundamental theorem of calculus. Now let us go back to the same problem, and we said find the area under the curve parabola where your x belongs to the interval 0, 1. But that time we were splitting the whole region, this region, we were splitting it into rectangles, remember? No, we don't need to do that now. Now I have a much convenient method to solve this, and I will say, okay, using the FTC, the integral x square dx in the interval 0 to 1 is equal to f of the final point b, which is 1, minus f of 0. Now the only concern is to find this capital F. So this is equation 1. Now I need to find this capital F. This is small f. Keep this thing in mind. So this small f is x square. I am interested to find what was the capital X, what was the original function on which I applied the derivative to get this. So now from the calculation starts from your mind, and you say, okay, if I have a function like this, and if I apply a derivative on this, that is d by dx of this capital F, that is d by dx of x cubed by 3. The answer will be what? The answer will be 3x square divided by 3. This is cancelled, this is x square. This is exactly what? This guy, which is small f of x. So it means this is the actual culprit, which I name as capital F of x. So I just pick up this one and put it into the formula. So when I will put it there, the answer will be, it is, what was that? It was x cubed by 3 at the point 1 minus x cubed by 3 at the point 0. Now this simply means, I told you that this means whatever the expression is, wherever there is x, put this 1. So it is 1 by 3 minus, this is 0 by 3. So it is 1 by 3. So the area under the curve for this interval x square dx is 1 by 3. That's it. And if you go back, recall, the answer was same or not? In this case, what was the answer when you applied limit n approaching to infinity, summation I from 1 to n, f of xi del x, and you got something like 1 by 3. And you said approximately equal to 1 by 3. But here you don't need to write approximately equal to. You will say, okay, the answer is 1 by 3. So whatever functions we have done using the Riemann sum, you can check them into the integrals and you will find the same answer. But you always have to check that your function should be continuous. Here. If the function is not continuous, then you have to, if it is a definite integral, you will say no, it's not possible. If it is indefinite integral, you will exclude that point from the interval and you will say, yes, the area under this curve for this whole thing is this function, such that you will always get the answer in terms of function when you will be talking about the indefinite integral, such that the x does not belong to 0 or whatever is the number of the discontinuity. Who is listening to the radio?
No.
I heard some voice.
Me too. It's not from my hand. I don't know who he was. He just muted. Can we take a break?
Okay, one more example. The example is find area under the cosine function and the interval is 0 to b, and where b is in between 0 and pi by 2. We have already done this example maybe using the same Riemann sum. So for area under the curve means integral from this to this. So in specifically talking, if you are taking the integral 0 to b, then what is the function? The function is cos theta, cos x, whatever you say, dx. Now the FTC says that answer to this integral, and you know that in between this interval cos theta is always valid. It has certain values. Whether you put 0, cos of 0 is 1, and when you keep increasing the values up to pi by 2, the values exist. So it means this function is continuous on this interval, so no problem. So this is what? This is the same f of x. If you compare this into the formula was a to b f of x dx, right? So this is what? F of x is cos of x, dx is same, and 0 to b, a is 0, b is same. Now I need to go back and see that which function, when I apply the derivative on that function, I get this function. So you already know the table of trigonometric functions. If you have the function sine x and you apply the derivative on sine x, what will be the answer? Cos x. So you are getting this thing from this function when you apply the derivative on it. So it means this thing is my capital F in this question. So I have got the capital F. Now I can convert this thing into the formula. The formula says that if you have this kind of situation and the function is continuous on the interval, then the answer is simply the antiderivative at b minus the antiderivative at a. I already have got the antiderivative, which is sine x. So the answer is sine at b minus sine at a. And sine at b, if I specifically take b equals to pi by 2, then it is sine pi by 2 minus sine 0 is 0 and sine pi by 2 is 1. So the area under this curve for this interval is 1. And if you draw this function, cos function, for example, the cos 0 is always 1. So your actual function starts from 1 and it always goes like this. You know this. It's a zigzag, a cos function. So the area under this region in between 0 and pi by 2, area under this region, we have found it 1. So it is what? It is the area of a square box. A square box. Anyways, you don't need to worry about these things. Only concern is calculation. Question?
No.
Indefinite integral. If we are not bound in a certain limit, then the answer will be a function. It will not be a number. And if you recall the last lecture of Advanced Mathematics 1, what we are talking most these days, the antiderivative guy. This guy is actually an indefinite integral. And it is not always bound in a certain domain. In that case, you will simply write integral f of x dx, and this equals to the capital F of x. Now we are moving towards the general formula of integration. So if you have a function with dx, then the answer of this whole integral on the left hand side is actually equal to the antiderivative of this function. That's it. In the function form. If you recall FTC part 2, we said that integral f of x dx, this is the answer for this is the antiderivative at the point B minus at the point A. This was FTC part 2 for the definite integral. Now we are switching towards the indefinite integral, and we say that if there is no bound, lower and upper bound, and this is the function dx, of course a general function, whether it is continuous or not, then the answer of this whole thing on the left hand side is actually equal to the antiderivative of this function. For example, if you have x square dx, very simple function, then the answer of this whole thing is the antiderivative of this function. What is the antiderivative? The antiderivative of this function is this. You know this. If you take the derivative of this function, you will get x square. If you take the integration of this function, you will get this guy. So it means these two are the reverse process. When you take the integration of a derivative, you get the actual function. Now on this function, when you apply the derivative, you move to this inner function. So that is why we say that integration and derivative are reverse process. Now one thing more. When we will talk about the indefinite integral, this guy has this answer, which is an antiderivative, but you will write a constant c whenever you will write an answer in this form. Only for the case indefinite integrals, when there is no upper limit, lower bound. When there is some bound, lower limit, upper limit, the answer will be an exact number, a real number. But when there is no upper and lower bound, then your answer will be a function plus some constant c. Now why adding this c? Go back to the original function x cubed by 3, and when I take the derivative of this function d by dx of this function, the answer is x square. 3x square divided by 3, 3 cancels, x square. Now this is 1. Also, if I take x cubed by 3 plus any constant c, for example, say I take 5, and now this is another function, and if I take the derivative of this function, when you take the derivative of this function, the answer is x square. This is 2. So you see, when you take this function without addition of a constant, the answer is x square. When you take the same function, but in addition to that there is some constant number is added, and when you take the derivative, the answer is again same. It means this function has two antiderivatives, either a simple x cubed by 3 or in x cubed by 3 plus any constant number. This could be 5, 6, 0, 1, 3, 2, 5, 200, any number, but a constant number. There could be a constant, and now who knows which x square in between these two x square, which one is this? Both are same. So that is why whenever we will talk about the antiderivative, we say, okay, yes, this is the antiderivative, but there could be a constant also. So we will say, okay, plus c. Now, if there is no constant, when we apply the limits, that is the next step. We are not going to do it in this course. When we apply the limit, we can also figure out what could be that constant. But that is a different thing. That maybe we will talk about those things in the differential equations chapter 9, 10 maybe. But at the moment, we don't care about what is the value of this c. But instead of only this function as an antiderivative, you will write plus c. Do you understand this?
No, again please.
Okay. This definition is very simple. In case of definite integral, there is an upper and lower bound on the integral and the function, and the answer will be a real number. Your answer will always be a real number, whatever number it is. So this is the definition of a definite integral. An indefinite integral definition written on the page is simply when your integral is not bound on any interval and you are talking about the infinite space inside the same function. This was the definite integral formula inside the same function f of x dx. Now, here you said if you have the lower and upper bounds, then the answer will be the answer is still the antiderivative, but only that portion of the antiderivative which is in between b and a. You are actually doing what? For example, if this is the whole infinite space and this is the region which is in between a and b. So when you solve the definite integral, if there is no limit on the integral, then your answer will follow this whole region. But when there is limit, what you do? You exclude this which is f of b and the internal part which is f of a, this lower boundary, you say this is f of a. Now when you subtract this whole region minus this, what you get? You only get this small region, which is the difference of the whole domain minus these endpoints. The same like when we are on the real line, one dimension, if you have these 2 points, you are starting 0 is here and this is a and this is b. Now this whole distance from 0 to b, this is b, from 0 to b. But if you are interested only in this region, what you do? You say this is b minus this point a. So when you do b minus a, the answer of this is this distance, which is equals to delta x, whatever it is. So the same thing, when you have a boundary, the general antiderivative will give you the whole infinite domain f of x. This will give you the whole infinite domain. But when you have a boundary, then you are actually into the whole domain, you are picking up that small portion. If this is infinity, then this means only this portion. I am interested to pick up only this portion. So putting these endpoints, I have selected this point. and I tell yes, this is the answer out of this whole infinite domain. Anyways, here when we talk about the indefinite integral, we remove the lower and upper bounds, the function is same and the answer is same. The answer is again the antiderivative. But this antiderivative is for the whole domain of x, which may be infinite. Here, this antiderivative was only in between a and b. So here you were limited to a and b to the certain domain. Here your answer is for the whole domain of x. Now wherever the value of x will go, the answer will change. In this case, the answer will be, for example, 13. It's a fixed number. Now, in this interval, this is the answer and that's it. So it has nothing to do with the values of x and y. The answer is 13, whether x go or not. In this case, when you will solve this integral, the answer is again the antiderivative, but this will be a function of x, whatever is used here. This is the thing which will define this inner thing. So whatever is the variable used here, the answer will be the same variable, but it will be going into the infinite domain. So the answer is same. This is the definition of indefinite integral. But one thing more we are going to add into indefinite integral, that whenever you have an indefinite integral, you will not only write f of x, but you will write f of x plus c, because there was some antiderivative function, but there could be a constant c which during the derivative became 0. Now I am going to tell you from where this c is coming. Suppose take the simple function x square, we have solved already, dx, and we said that we have to find the antiderivative of this function. So if you recall, if I have this function x cubed by 3 and I take the derivative of this function, then I can get the answer x square, this answer. So it means this is the original capital F. When I apply the derivative, I get x square. Now, so it means on the right I got f of x. But suppose, now let it keep it as 1. Suppose I have another function, the same x cubed by 3 plus 5, or any number, say plus 1, plus this is a constant. And if I take the derivative of this function, this whole function, then the derivative of this whole function means the derivative of this plus the derivative of this. The derivative of this gives me x square, plus the derivative of 1 gives me 0. So this is removed. The answer is again x square. Now compare the two equations, 1 and 2. Both cases the answer is x square. Just I sometimes write capital R's. Meaning is same. Both cases the answer is x square, but the functions are different. Now suppose we have another function, x cubed divided by 3. This is same. This thing is coming same. Plus, instead of 1 I have 10. And I apply the derivative on it. I will get the same answer, x square. So whether you keep this constant or you keep changing. In this case there is also a constant, but it was 0. It was x cubed by 3 plus 0 and it gave me this answer. But instead of 0, if you have a number, positive or negative, your answer will again be x square. Why this? Because the derivative have removed that constant, because the derivative of a constant is 0. It means there could be a function having 0, like x cubed by 3 plus 0, or any plus or negative number. I don't know which number. I don't know which x square. I have, for example, in these three cases, I have 3 answers x square. I don't know which one is this. Whether this one, whether this one, whether this one. If this x square is this one, then there should be x cubed by 3 as the antiderivative, no c. If this x square is taken from 2, then f of x by c and f of x should be this one, x cubed by 3 plus 1. If this x square is this one, then it is x cubed by 3 plus 10. Now there are infinitely many cases for all the real numbers which can give me this answer. So I don't know which x square is here. So I say, okay, whatever is there as a constant, whether it exists or not, I say, okay, this is common. X cubed by 3 is common. So I say this is f of x is common, plus there could be a constant or not. There could be a constant 0, there could be a positive number or a negative number. So I will always write a capital C. Understand?
Yes, yeah.
So this is the integration, the constant of integration, which you always see in your solutions. Where this coming from? This is coming from that ambiguity which was coming into the derivative. So the problem coming from the derivative, if you have x cubed plus 1, then the derivative of this thing is x square. This 1 is removed because of the derivative. So when you will go back, you never know, when you don't know this thing and you are trying to go back from x square to the original function, you don't know what was added into x cube. So you have to generalize.
We can never know this.
No, we can know. We will learn the process of finding this C, but that process will be into the differential equations, maybe the last chapter of our this subject. But at this moment, we don't need to know about this C.
It will be a mystery.
Yeah, it will be when we will have certain boundary conditions, and like for example, you solve the integral, you got the function plus C. Now you apply the boundary conditions. When you apply the boundary conditions, you will get the C.
Right.
Initial and boundary conditions. But we will definitely, that differential equations introduction is the part of this course. We will try to reach there, but that will be maybe the last chapter. Anyways, so the point of interest is that in the indefinite integral, the answer will always be, whatever here it is, the answer will be a function. This thing is important. Any function, and this function will always be a type of some f of x, g of x, h of x plus c of integration. So you will always have a choice to have a constant number of your choice. For example, you instead of c, if your answer is coming, for example, your answer is coming ln of x, then you can say, okay, there could be a constant ln of c. This is a constant. Whether you take c or ln of c, again a constant, you don't know. So you can always take it so that you can combine them and you can say the answer is ln of x. Now these two are same, but this looks beautiful. So you can always have a choice to decide the appearance of this constant. You are free.
Okay. Right. One extra article making it beautiful.
Yeah, that's why they say that it's the calculation is always weird in mathematics, but the answer should look beautiful. You should do such kind of simplifications that it should look beautiful. So the general formula for indefinite integral f of x, if you have a function in this form, the power rule. If you go back to the derivative stuff, when you take the derivative of x raised to the power n, you say the n appears here and the power becomes 1 less than n. So in this case, in the case of integral, if you have this kind of function, then it will be x, the power will be added and the whole thing you will divide. So the formulas have some similarities, but the operations are different. In that case, you take one n there and the power is reduced by 1. Here the power is increased by 1 and the whole thing is divided. Here the whole thing is multiplied. So here the thing is divided. That's why these are the reverse process. If here it is added, here it is subtracted. Here it is multiplied, here it is divided. So in integration, if you take that, now this is what x, and this formula for the derivative was valid only for the polynomial functions of this kind. Similarly, this formula is only valid for the polynomial functions which have this kind of a shape. For example, x cube plus x square plus 1, something like this. So these are the polynomials. Now, one interesting thing. You are asked to find the integral of this function. Yes, but you are not bound on any interval. Now, previously we said when we were taking 1 by t square, the same function it was. So you can take it as, okay, 1 by t square dt, so that you don't confuse. Previously when I explained to you that if you have this kind of function in between -1 and 1, what happened? We said there is a value when t equals to 0, this function becomes infinity, so it is not possible to solve this integral, right? Remember? Today
Yes.
we had this function, and I told you that in between -1 and 1 there is a number 0. When I put this number into this function, it violates the fundamental theorem of calculus. Now, in indefinite integral, you will not tell me this. You will give me the answer and you will say, okay, I can solve this. This will be, you can keep this upside, t raised to the power -2 dt, and apply the same power rule which I just told you, which is t raised to the power -2. This is your n, and the power rule says whatever n, add 1 and divide this whole guy with the same thing, plus the constant of integration. So this is what? This is -1 divided by t plus c, right? This is the answer of this function dt. But previously I said this is not possible, and here I am giving the answer. This rule is same, again same. This function should always be continuous, but here, since I am talking about the whole infinite domain, so I will here separately I will tell such that the t is not equal to 0. If t is not equal to 0, all other domain is fine, and the answer is this. So you can write this answer in this form. You will say, yes, the area under the curve, whatever this curve is, the area under this curve is -1 by t plus, say, c1 when your t is less than 0, and -1 by t plus, say, c2 when your t is greater than 0. And this function is not valid if your t is exactly 0, which I have already told you, don't need to mention. So your answers are actually this, or you can simply write it this. Both are fine, but this is the more general explanation that what will be the regions of this answer. This answer when the t is less than 0, not 0. This answer when the t is greater than 0. Both answers are same because this is same. But when less than 0, I had some other constants. When greater than 0, I had some other constant. But at t equal to 0, no answer. So the situation is again same. But here you were bound in this interval, this definite interval, finite interval. So you said no, the function is not continuous here. So you will just tell me not possible. But in the case of indefinite integral, you will specifically pick up that point and tell me, yes, the answer is this, but this point is a culprit. Here it is not possible, otherwise it is okay. So since this is a function, it's not a problem. In this case, you were supposed to find a number, and to find a number, you needed all these points. To find a function, you don't need any points, but you can tell me, yes, when you will be crossing the boundary, you will be starting from -infinity going toward the plus infinity. When you will be walking, there will be a point 0, which is a dangerous point. When you will be walking, just skip it and go. Don't cross this point. It will be a problem for you. You will fall down. So that's why you mentioned here that no, don't touch this guy. This is a 11,000 voltage electricity current.
Okay.
Okay, similar simple examples, but let's do to have more practice, and then I will give you more questions later in the homework. For example, if you have this 2 secant square x dx, have I already? Okay, let us first write the some basic formulas for the integrals. Okay, so there are some basic indefinite integrals. I means indefinite integrals. The first one is these are the rules, just like we defined some rules when we were talking about the Riemann sum. So similar is the case here. If you have an integral such that there is a constant number, there is a function and dx, then you can take that constant outside the integral. It has nothing to do with the integral, and you can solve this integral and then multiply it. For example, if you have integral 5x dx, then you can do that. You can take the integral outside and you can have it x dx. But when there is an integral and this function dx and there is a function of x, then you are not allowed to, and in any case, to take it outside the integral. You can never do this integral dx. No, this is illegal, because this function is under this integral. You are not allowed to keep this variable function outside. But if there is a constant number, you can always keep it inside or take it outside, just for your simplicity. Both are okay. Just the same, if you go back to the summation, we said if you have summation c f of x delta x, then it doesn't matter. You can keep c outside and do the summation on f of x delta x. The answers will be same in both cases. Remember? The second rule is, if you have an integral on sum of two functions, there is a function f of x plus there is a function g of x and whole dx, then you can simply write this as sum of integral of the function separately plus integral g of x. Just like if you recall the derivative, you said that if you have to find the derivative of two functions, f of x plus g of x dx, then it is simply the derivative of the first function plus the derivative of second function. Remember? So similar is the case here, that it is simply the integral of first function plus the integral of second function. And just like if you go back to the summation and you said sum of something c delta x, something like this, I don't remember, yeah, it was, you said that the answer will be c into b minus a, something like this, if you recall. Remember? I'm not sure what was this, but something like this. Similar is the case here. If you have some constant c and simply the dx inside the integral, so there is no other function but a constant, the answer will be cx plus any other constant k. The answer will be cx. If there is no x involved, then in the answer you will have 1x. If there is no x involved, just like this. But this was the case for the boundary, this is case for the indefinite integral. That's why there we have x. If this was the case with the definite boundary, then this x will again replaced with b minus a. Same thing. the key thing in mind that if there is no function involved, there will be one value of x. So in general, this rule goes for this. If you have this, then the answer will be xn plus 1 divided by n plus 1 plus c. So the general rule for a polynomial function stands like this. And if you have integral sine x dx, then the answer will be, go back, recall the antiderivative. You need to find an antiderivative of this guy. So in the case of sine x, if you have sine x, then the derivative of sine x is what? It is cos x. And if you have cos x, then the derivative of cos x is minus sine x. But I need a positive sine x. To get a positive sine x, I need something here so that this should be positive. If I take it as a negative cos x, then the derivative of negative cos x will be a negative into negative sine x, and it will become positive sine x. So it means the actual f of x, the antiderivative, will be minus cos of x plus the constant of integration. Do you get it? And you can see the reverse process. In the case of sine x, you took the derivative, the answer is cos x. In the case of sine x, you took the integral, the answer is minus cos x. See there. When you were taking the derivative of sine x, the answer is plus cos x. When you are taking the integral of sine x, the answer is minus cos x. Compare them. Yes or no? Say something. So they are telling us at every stage, yes, we are the inverse process. Similarly, if you have integral cos x, then you can talk about the antiderivative of cos x. What will be the antiderivative? If you start with d by dx of sine x, then the derivative is cos x. So it means this guy is the antiderivative for this function. So the answer will be what? Sine x plus c. Right? Similarly, integral secant square x dx, and the answer will be tan x. You have this thing written on the pages. You can see these rules. All formulas are written. The concept is same. If you want to check that you are right or not, take the derivative of this right hand side. If you take the derivative and you get this guy, it means you are right. All these things. For example, if we are standing at this one, number 5, I am giving you an expression and I say, check this formula is true or not. So instead of checking this, check from here. Take the derivative of this thing, d by dx of minus cos x plus c. When you take the derivative, this minus is outside, and the derivative of cos x is minus sin x, plus the derivative of c is 0. Minus minus plus, this is sin x. This is same which is here. So it means this formula is correct. So if you want to check an integral formula, start from the right, take the derivative and see if this inner guy is obtained or not. Because this is an antiderivative of this inner boy, and this is a derivative of this outer boy. And that is what the fundamental theorem of calculus. Fundamental theorem of calculus, that g dash of x is actually the inner function f of x. Okay, simple examples. Okay, let us recall first. we are now actually trying to see the results as compared to the Riemann sum. We are again going to recall an example, and there was an example. We said that find the area under the curve, we said that find the area under the curve when the function is f of x is x cube minus 6x. Remember? And the x belongs to the points 0 and 3. So we are inside the definite integral. If we are inside the definite integral and I am asked to find the area under this curve, then what will be the formula? The formula will be a to b 0 to 3 f of x dx, that is integral 0 to 3. What is f of x? This guy, x cube minus 6x into dx. Now I know the rule that if you have a sum of two functions, I have two functions. One function is x cube, other function is negative 6x. I told you in mathematics there is nothing about, there is no meaning of minus. A minus is always sum of two things. A minus b is actually a plus negative of b. This is true. This is the simply beautiful version. But actual thing is this. Similarly, this is a beautiful version, but actual thing is 0 to 3 sum of x cube and negative of 6x into dx. I know the rule just before I wrote that if you have sum of two functions f of x plus g of x, then you can split them, integrals on them. So it is 0 to 3 x cube dx separately plus 0 to 3 minus 6x dx. Now again, this is simple, the power rule, xn plus 1 divided by n plus 1. So it will become x4 divided by 4, but on the limits 0 to 3. 0 to 3. You will write the limits like this, closing bracket and the lower limit and the upper limit. Plus this symbol, and this is the constant. I told you if there is a constant with a function inside the integral, take that constant outside. So I can take that constant outside. This plus will become negative, and the inside integral is 0 to 3 x dx. Okay, this will be, when you put the values here, it will become 3 raised to the power 4 divided by 4. When you have limits like this, then first you will put the b point. This is what? This is f of x, capital F of x, the antiderivative. This is an antiderivative of this function. So you know the rule that when you get the antiderivative, the rule is f of b minus f of a will be the answer. This is f of x. It means you will put the point b first. 3 raised to the power 4 by 4 minus f of a means the whole function, but the point a, that is 0 power 4 divided by 4. This is first part, this part, minus this 6 into the second part. You can see this is again a simple polynomial, x raised to the power 1. So same formula you can apply, that is x square divided by 2. 1 plus 1 divided by 1 plus 1, x square divided by 2, and the limits from 0 to 3, plus, since the answer is in the definite integral, so we are not going to write that plus c. I told you this we will always write if we don't have these limits. So we are not writing that c. Now simplify this. This is cancelled. This is 3 by 4 raised to the power 4 divided by 4 minus, when you put 3 here, it becomes 6 into 3 square by 2 minus from the formula, this formula, and 0 square by 2. Simplify this. The answer will be 81 by 4 minus, this will be 54 by 2, 27. And when you simplify it, the answer is yeah, this is okay, minus 6.75. So the answer of this function, area under the curve, for this function on this region, the area under the curve is minus 6.75. If you go back and recall, we did this example before. First we did this for 6 or 4 intervals, and for the 4 intervals the answer was something minus 3 point something. Remember? Something like this. Remember? And I told you that if you calculate, and we said we were using the right end points, and we calculated R4, the answer was something like this. And I told you, if you calculate R40, split the region into 40 slices, the answer will be something like minus 6.627, something like that. I'm not exact, but somewhere here. So the guy was going closer to there. But here in this case, we exactly got the answer which you will get for what? When you will split this guy into infinitely many intervals. When you use the same method of right hand points, the answer for R infinity was minus 6.75 something, which is exactly the same answer which we have got by using the formula of the integral. We didn't get these things because these were the big margins of error, and the integral is always the minimized error, which you can only get in case of infinity using the Riemann sum. So limit n approaching infinity is equivalent to the integral 0 to b. So wherever we will do the integrals, you can compare the answer of the infinity for the Riemann integrals and the answer of the exact formula of the integral will be equal. Okay? Any question? We will continue from here onwards tomorrow.